Right, well hopefully this video will demystify this whole thing pH. You use it a lot, you probably use it right from year 7, maybe even earlier. But what is pH? Well, it's simply the minus log of the H plus concentration. H plus is what makes something, or the ability to donate H plus is what makes something acidic. The more H plus you donate in solution, the more acidic you are. But comparing H plus concentrations can be tricky, so it can be very small numbers times 10 to the minus numbers. So we have a scale, a logarithmic scale, to make it easier to compare. So if you know the H plus concentration, you minus log it, you get the pH. You can reverse that as well. If you know the pH, 10 to the power of the minus pH gives you the H plus, which can be useful as well to work out concentrations. So let's have a look at how this works. So we keep it simple. We'll look at monobasic strong acids. Here's HCl dissociating. Whatever your concentration of HCl is, one mole of this will make 1 mole of that. So whatever your concentration of HCl will be the same concentration for your H plus. Okay, so more generally, we're saying that the concentration of HA equals the concentration of H plus. So if you want to know what the pH is, just substitute in the concentration of your acid. So here's a few examples. If you had 2 moles of dm cubed of HCl, it's going to use that 2, because if that's the concentration of HCl, it must also be the concentration of H plus. So minus log 2 equals minus 0.30. Oh, that's something we weren't expecting. Got a minus pH. That is possible. Not even particularly strong acid, 2 moles per dm cubed. If we take more dilute acid, nitric acid, 0.1 moles per dm cubed nitric acid, minus log it, or pH of 1. 0.01 moles per dm cubed, we have a pH of 2. So you can see going from pH 1 to 2 sounds like not a big change in pH, but actually in terms of concentration of the acid, it's got 10 times more diluted in terms of H plus, a logarithmic scale. Here's looking at the problem from another point of view. We know the pH, but we want to know what the concentration is. So we're using that rearrangement of the pH equation, 10 to the minus pH. So we do 10 to the minus 2.5 because we said that's what the pH was in this case. And that gives us this concentration of H plus. And if the H plus concentration equals the HCl concentration, it must be 3.16 times 10 to the minus 3 moles per dm cubed.